All right, let's take a look at our practice test. We're told here to solve each equation and state the equation type. So let's come down here. Let's look at equation number 1. So we have this negative 4 times the quantity x minus 6 plus 11 times the quantity x minus 6. This is set equal to negative 2x plus 12x. Okay, so on the left, I'm just going to use my distributive property to clean things up. Negative 4 times x is negative 4x. And then you'll have negative 4 times negative 6. Let's put plus 24 like this. Then we'll have plus 11 times x is 11x, so plus 11x. And then basically minus 11 times 6 is 66. And let's set this equal to, over here on the right, let's just copy this. So negative 2x, then plus 12x like this. Okay, so on the left, I can clean up because I have negative 4x plus 11x. That's going to give me positive 7x. And then 24 minus 66 is going to be negative 42. So let's put minus 42 like this. And this equals, on the right, I can combine like terms. Negative 2x plus 12x is going to be positive 10x. And let's go ahead and say that we're going to subtract 10x away from each side of the equation like this. And I'm going to add 42 to both sides of the equation like this. And let's go ahead and cancel this guy here and this guy here. And so 7x minus 10x is going to be negative 3x. And this is equal to, let's go ahead and say this is 42 over here. And then to finish this off, I want to isolate x. Let's divide both sides by negative 3. And let's go ahead and say that x is equal to negative 14, right? 42 divided by negative 3 is negative 14. The idea here is to determine if the equation is conditional, an identity, or a contradiction. So because this guy, we're solving a linear equation in one variable, because this guy has one single solution here and one single solution only, we can say that this is a conditional equation. It's true under the condition that x equals negative 14. It's false for any other value of that variable, right? If I said x was negative 13, it wouldn't work, right? It would not solve the equation. So this is a conditional equation. Conditional, like this. Let's look at problem number 2. So we have negative 2 times the quantity 6x plus 6 plus 11. This is equal to the negative of the quantity 1 plus 12x. All right, let me slide down here. Again, I'm just going to clean up with the distributive property. Negative 2 times 6x is negative 12x. Then negative 2 times 6 would be minus 12. And then we have plus 11 here. This equals over here. If I have a negative in front of some parentheses, I'm just going to change the sign of everything inside. So it's like multiplying everything by negative 1. So this would be negative 1 and then minus 12x. Again, just changing the sign of everything and dropping the parentheses. All right, so what do we see? On the left-hand side, I can combine like terms. Negative 12 plus 11 is going to be negative 1. So I have negative 12x minus 1. And over here, I could actually rearrange this to have negative 12x minus 1 as well. So if you see the same thing on each side of the equation, you know that no matter what you plug in for x, it's always going to be true, right? Because the same thing is being done. Here, when I plug something in for x, I multiply by negative 12, and then I subtract away 1. Same thing happens over here. So it doesn't matter what the value of x is that I choose. So this is called an identity. And you could also go through the full process. So you could add 12x to both sides of the equation. So this is gone over here and here. You could add 1 to both sides of the equation. So it's gone here and here. So basically you get 0 equals 0, okay, which is a true statement. So this is an identity. It's true no matter what you replace x with. So we'll say this is an identity. Let's take a question 3. So we have negative 12x plus 8x is equal to negative 8 times the quantity x minus 5, and then minus 10 times the quantity 1 minus x. All right, over here, I can just make this negative 4x if I combine like terms. This equals negative 8 times x is negative 8x. Negative 8 times negative 5 is plus 40. And then negative 10 times 1 is minus 10. And then negative 10 times negative x is plus 10x. If I combine like terms here, negative 8x plus 10x is going to be positive 2x. So let's just do this in line. I'll just say this is 2x like this. And then 40 minus 10 is going to be 30. So let's put plus 30 like that. I'm just going to go ahead and subtract 2x away from each side of the equation. So like this. And this will cancel. And I'll have negative 6x is equal to positive 30. Divide both sides by negative 6. And I'm going to have x is equal to negative 5. So this guy right here is conditional, right? Remember, it's true under the condition that x equals negative 5. It's false otherwise. So this, let me scroll down just a little bit more. This is conditional. Okay, so we have problem number 4. So we have 3x plus 11 times the quantity x minus 8 is equal to 2 times the quantity x minus 2. Let me slide down here. So this is 3x plus 11x, and then minus 88 is equal to 2x, and then minus 4. So just distributing things to clean up. On the left, 3x plus 11x is 14x, and then minus 88, and this equals 2x minus 4. Let's go ahead and subtract 2x away from each side of the equation. Let's also go ahead and add 88 to both sides of the equation. So we'll see that this is going to cancel and this is going to cancel. So 14x minus 2x is 12x. And this equals, if I do 88 minus 4 or negative 4 plus 88, however you want to do that, you're going to get 84. So divide both sides by 12 so you can isolate x. And you get x is equal to, let me slide down here, 84 divided by 12 is going to give you 7. So x equals 7 is your solution. So again, this is conditional. This is conditional. All right, let's look at problem number 5. So we have negative 8 minus 5 times the quantity x plus 9. This is equal to negative 3 times the quantity x minus 8, and then we're subtracting away 2x. Let me write negative 8, and then negative 5 times x would be minus 5x. Negative 5 times 9 would be minus 45. This equals, over here, negative 3 times x is negative 3x, and then negative 3 times negative 8 is positive 24, and then you have minus 2x. So on the left, negative 8 minus 45 would be negative 53. So basically you have negative 5x minus 53 like this. Let me rewrite this so it's a little bit cleaner. On the right, you have negative 3x and negative 2x, so that's negative 5x also, and then plus 24. So let's pause for a minute and think about this. Is there anything I can possibly plug in for x that would give me a true statement? No, because the same value would be here as here, no matter what I plug in for x. And basically, I'm subtracting away 53 from it here, and I'm adding 24 to it there. How could they ever be equal? They can't be, right? Another way to think about this, I could simply add 5x to both sides of the equation here. This would cancel and this would cancel, and I'm left with negative 53 is equal to 24, right? So this is a false statement. So if your variable drops out and you're just left with this false statement, you can say that you don't have a solution. So you could write no solution like this, right? A lot of people put the symbol for the null or empty set. So you could do that if you wanted to. But the main idea here is to identify the type of equation. And this type of equation is called a contradiction. So a contradiction. Okay, let's look at number 6. So we'll come down here. We have 7 times the quantity x plus 1 is equal to negative 1 plus 7 times the quantity x minus 2. So we're going to get 7x plus 7 is equal to negative 1 plus you're going to get 7x minus 14. So again, you can already see you're going to have a problem because you have 7x over here and 7x over here. And basically, if you combine like terms over here, let's just put 7x plus 7 is equal to negative 1 minus 14 is going to be negative 15. So this is 7x minus 15. This you can just go ahead and cancel, right? If I subtract 7x away from each side, it's gone. You're going to be left with 7 equals negative 15. So 7 equals negative 15, which is false. So again, you have a situation where you have no solution, right? So you could write no solution. A lot of people just, again, write this symbol for the null or empty set. And again, the type of equation here, we're dealing with a contradiction. So this is a contradiction. Contradiction. Okay, let's look at problem number 7. So it looks like we have a lot of work to do on cleaning this up, but we have the negative of 3x plus 1/3, so this quantity, minus 2/3 times the quantity 5 halves x plus 3 halves. This equals 4/3 x plus 1/3 x. So I would apply this negative first. So this would be negative 3x and then minus 1/3. Just applying that negative to each term inside. Then for this guy, you have negative 2/3 times 5 halves. The 2's would cancel and you would have basically negative 5/3 x like this. Then if you're dealing with negative 2/3 times 3 halves, well, this is basically going to be negative 1. Right? So we know it's negative times positive, that's negative, and then 2/3 and 3 halves, those guys are reciprocals, so the result is 1. So then this equals 4/3 x plus 1/3 x. So all your fractions have a denominator of 3, so you can just multiply everything by 3 and clear all your denominators. Let's go ahead and do that real quick. So this would be negative 9x minus, this would be 1, then minus 5x, and then minus this would be 3. So I just multiply this by 3, this by 3, this by 3, and this by 3. And this equals, got to do the same thing over here. So this would be 4x, and then plus this would be 1x or just x. Negative 9x minus 5x would be negative 14x. And then negative 1 minus 3 would be minus 4. And And this equals 4x plus x would be 5x. So I'm going to subtract 5x away from each side of the equation and add 4 to both sides of the equation. And again, in terms of what's going to cancel, this is going to be gone and this is going to be gone. Negative 14x minus 5x is going to be negative 19x. And this is going to be equal to positive 4. To finish this up, let's just divide both sides by negative 19, like this. And we really can't simplify that fraction. We're just going to say x is equal to negative 4/19. Now for this guy right here, this tells us we have a conditional equation, right? It's true under the condition that x equals this negative 4/19. So let's go ahead and put this as conditional. All right, let's look at problem number 8. So we have this negative 7/2, and then let's go ahead and distribute this. So negative 1/3 times x would be minus 1/3 x. Then negative times negative is positive. 1/3 times 7/2 would be 7/6. And this equals, let me distribute here as well. So negative 1/3 times x is negative 1/3 x. And then if you do negative 1/3 times 3/2, this is going to be negative. The 3's would cancel, and you'd have a half. Okay, so the LCD here would be 6, right? Because you have a denominator of 2, 3, 6, 3, and 2. So just multiply everything by 6. So basically, if I multiply this by 6, 6 divided by 2 is 3. 3 times negative 7 is negative 21. And then minus 6 divided by 3 is 2. 2 times 1 is 2, and then times x, so this is 2x. And then plus 6 divided by 6 is 1, so this is just 7. I can go ahead and do negative 21 plus 7, that's negative 14. So let's make this negative 14 like this. Let's put equals. I'm multiplying this by 6. 6 divided by 3 is 2. So this would be negative 2x like this. And then minus, I'm multiplying this by 6. 6 divided by 2 is 3. So this would be a 3 here. Now, you see there's a problem because you have negative 2x here, negative 2x here. So if you cancel that on each side, you're left with negative 14 is equal to negative 3, which is obviously false. So we can see here again we have no solution. Again, you can write your symbol for the null or empty set. You could write out no solution. Again, whatever your teacher wants. But the idea for this exercise is to note that this is a contradiction. All right, let's look at problem number 9. So we have this negative 2.4 times the quantity 0.6 plus x is equal to, we have this negative 3 times the quantity 0.95 plus 0.8x, and then minus 2.5. Okay, let's see what we're looking at here. I'm just going to clean up using the distributive property first. If you punch this into your calculator, negative 2.4 times 0.6, this is negative 1.44. And then negative times positive is negative, so this would be negative 2.4x. And this equals negative 3 times 0.95 would be negative 2.85. Let me make this better. And let me actually make this x better here. Doesn't look so good. And then we're going to have negative times positive, so that's negative. 3 times 0.8 is 2.4. And then x would come along for the ride. And then you have minus 2.5. So again, you can already see that there's a problem. You have negative 2.4x. You have a negative 2.4x. So without going any further, you see the variable is going to drop out, right? Because it's going to cancel from here and here. And you're going to be left with a false statement, right? So I can say that there's no solution here. So this is a contradiction. Okay, let's look at the last problem. So problem number 10. Let's come down here. We have 0.2 times the quantity x minus 2.1. This equals 1.3 times the quantity 1.1 minus x, and then plus 1.1x. All right, so this first one would be 0.2x, and then minus. You multiply this guy right here, 0.2 times 2.1. That's going to give you 0.42. And this equals, you're going to have 1.3 times 1.1. That's going to give you 1.43. And then minus 1.3 times x is 1.3x. And then plus 1.1x. And if you want to, you can clear all the decimals. Again, I usually don't do this because we work with calculators anyway. But let's just go ahead and do it for the sake of completeness. The largest number of decimal places is 2. So I'm going to multiply everything by 100. So this would be 20x minus, this would be 42, is equal to 143. And then minus 130x. And then plus 110x. So then just combining like terms over here, let me put 143. And then negative 130x plus 110x is going to be negative 20x. let's put 20x over here and minus 42. Now 20x is not the same as negative 20x, so don't immediately exit the problem there and say you have no solution, because in this case I can add 20x to both sides of the equation, and of course this is going to cancel, and I can add 42 to both sides of the equation, so this guy right here is going to cancel. 20x plus 20x is going to be 40x, and this equals 143 plus 42 is 185. So let me make that a little bit better there. Let me divide both sides by 40, and I'm just going to answer this as a decimal. So I'm just going to say that x is equal to, let's punch this into the calculator, and we're going to get 4.625. So this is my solution here, and more importantly, it tells me that I have a conditional equation, right? The equation is made true by this value and this value only, right? So under this condition. So we'll say this is conditional.